Hi, I'm Alan, and this is my final milestone video for the Wi-Fi voice controlled robot project. So for this milestone, I was able to get the entire robot to work, basically move forward, move backward, turn left, and turn right. So here's a demonstration of the robot working. And I'm using this app, which I also made myself. So the app has 6 different buttons, which are forward, backward, right, left, and a stop button, and also a voice control button. So here's the forward button, backward, left, and right. And this is the voice control button, forward, backward. So that was my live demonstration. And the way I basically accomplished getting the motors to work during this final milestone and getting the whole robot to move was by connecting 3 different power sources. And if you saw during the live demo or heard, then you might have noticed that when there's only 2 wheels running at the same time, then it makes a louder sound, or basically that means it's spinning faster. But when there's all 4 wheels or motors working at the same time, then there's a less loud of a sound, which means that each of the wheels is moving at a slower speed. And this is due to each of the motors needing a certain amount of energy. So when I'm only able to provide a certain amount of energy, then each of the wheels have to like slow down to be able to use the same amount of energy. So originally, I only used 1 power source, and that really didn't let the robot run at all. And when I still use like 2 power sources, it wasn't really able to turn on the ground. So I solved this problem by connecting 3 power sources, which is a rechargeable power bank, a 9-volt battery, and also 4 additional 1.5-volt batteries. So I also use the Arduino as kind of a place to store all of the power temporarily, and then I could pull out certain amounts of energy when I need it later on, especially to power the ESP32, because one of the major challenges I had was the first ESP32 actually got damaged, mainly because I gave it 5 volts of power, which is way too much more than what it needed, which was around 3 volts of power. So I solved this problem by wiring the ESP32 and the Arduino together. So the ESP32 would draw out power from the Arduino's 3.3 volt pin. So now the ESP32 is able to function properly without any chance of getting it damaged. So as I move forward, I hope to slightly streamline the communication process between the app and the robot itself. And I hope to find possibly a better way of powering the entire robot. So I can either use less power sources, or use the same amount of power source, but make the power increase. So then the wheels will be able to turn even better. So the robot itself will move faster and also turn more smoothly.